The rise of quantum computing. Why Google and IBM are betting billions. Imagine a world where computers solve problems in mere seconds, problems that would take today's most powerful supercomputers thousands of years to figure out. It sounds like something out of a science fiction movie, doesn't it? Well, this isn't the future, it's the world of quantum computing, and it's becoming a reality. And the companies that are leading the charge? Google and IBM, two giants investing billions into this groundbreaking technology. As we embark on this journey into the heart of quantum computing, you'll see why it's considered the next big leap in technology, one that promises to change everything we know about computing, industry, and even the very fabric of our society. Before we dive deeper, I want to hear from you. Do you believe quantum computing will be the greatest breakthrough of the 21st century? Drop your thoughts in the comment section and let's talk about it. What is quantum computing? Let's start with the basics. Classical computers use bits, the smallest units of data, to process information. A bit can be either 0 or 1. Simple, right? But quantum computers work entirely differently. Instead of bits, they use qubits, short for quantum bits. What makes qubits so special is their ability to exist in multiple states simultaneously, thanks to a principle called superposition. That means a single qubit can represent both 0 and 1 at the same time, opening the door to much more powerful and efficient calculations. On top of that, there's another mind-bending principle called entanglement. When two qubits become entangled, the state of one qubit is instantly connected to the state of another, no matter how far apart they are. In other words, changing the state of one qubit will affect the other, even if they're on opposite sides of the world. The combined forces of superposition and entanglement allow quantum computers to perform certain computations exponentially faster than classical computers. It's like comparing a flashlight to a laser beam. The flashlight can illuminate a small area, while the laser can focus its power on an incredibly tiny spot, solving incredibly complex problems faster than ever before. In fact, just a few years ago, researchers at MIT published a study showing that quantum computers could reduce computation times for optimization problems from weeks to mere minutes, something that classical supercomputers could never dream of achieving. The current landscape: Google versus IBM. When we talk about the leaders in the quantum computing revolution, Google and IBM are two names that immediately come up. Both of these companies are investing billions of dollars into developing quantum technologies, but they're approaching the challenge in very different ways. Let's start with Google. In 2019, Google made history with its Sycamore processor. This quantum computer solved a problem in 200 seconds that would have taken a classical supercomputer over 10,000 years to complete. This achievement was referred to as quantum supremacy, and it marked a major milestone in the race to build practical quantum computers. But Google hasn't stopped there. Recently, the company introduced Willow, a new quantum processor designed to reduce error rates and improve scalability. While Sycamore was a proof of concept, Willow aims to push the boundaries of what's possible by making quantum computers more stable and effective for real-world applications. Now, IBM is taking a slightly different approach with its own ambitious plans. IBM's Quantum System 2, released in early 2024, is a highly modular quantum system with 156 qubits. But what really sets IBM apart is its focus on scalability and stability. The company's roadmap includes the Condor project, which aims for 1,000 qubits by 2025, with a strong emphasis on error correction and robustness. In terms of milestones, Google's Sycamore achieved quantum supremacy in 2019, followed by the introduction of Willow in 2024. Meanwhile, IBM introduced the Eagle processor in 2021, followed by the Quantum System 2 in 2024. Google's focus has largely been on speed and artificial intelligence optimization, whereas IBM is prioritizing stability, scalability, and error correction. Despite their differing strategies, both Google and IBM are racing to unlock the true potential of quantum computing. And while both companies have made huge strides, there are still significant hurdles ahead. Revolutionary applications of quantum computing. Quantum computing isn't just a theoretical technology. It's already beginning to change industries with massive implications for fields like medicine, finance, cybersecurity, and even climate science. Medicine and drug discovery. Quantum computers can simulate complex molecules in ways classical computers never could. For instance, quantum algorithms can model protein folding in days rather than years, which is a critical step in drug discovery. In 2023, Roche teamed up with Google Quantum AI to simulate protein folding, which could lead to breakthroughs in treating diseases like Alzheimer's. Finance and portfolio optimization. In finance, quantum computing offers the ability to analyze vast numbers of market scenarios simultaneously, optimizing investment strategies and reducing risks. JP Morgan Chase is already collaborating with IBM to explore how quantum algorithms can improve portfolio management. Cybersecurity and cryptography. Quantum computing computers could eventually break current encryption methods, making traditional security systems obsolete. In response, researchers are developing quantum-resistant encryption protocols to safeguard sensitive data from future quantum-powered cyber threats. Climate modeling and renewable energy optimization. Quantum computing also has the potential to revolutionize how we model climate change. Quantum algorithms can process enormous amounts of climate data in mere minutes, allowing for more accurate weather predictions and optimizing the placement of wind turbines to increase energy output. Researchers at MIT are already using quantum simulations to enhance the performance of renewable energy systems, such as wind farms. These are just a few examples of how quantum computing will revolutionize industries. From speeding up drug discovery to making financial markets more efficient and secure, quantum computing will have an unprecedented impact on nearly every aspect of our lives. Engagement prompt. Before we continue, I'd love to hear what you think. Which industry do you believe will be most impacted by quantum computing? Let us know in the comments section below. We've seen how quantum computing is set to disrupt industries ranging from healthcare to climate science. But the road to a fully functional quantum computer isn't without its hurdles. There are still major challenges that need to be overcome, both technically and operationally. So, what are the key obstacles standing in the way of making quantum computing a mainstream technology? The challenges of quantum computing. Despite the remarkable breakthroughs we've seen, there are still significant hurdles on the path to quantum supremacy becoming a day-to-day reality. Let's break down some of the biggest challenges facing quantum computing today. Stability and error. Correction. One of the biggest challenges quantum computers face is the fragility of qubits. Unlike classical bits, which can remain stable and store information in one of two states, qubits are extremely sensitive to external interference. Environmental factors such as temperature, electromagnetic radiation, and even small vibrations can easily disrupt the delicate states of qubits. This is a huge problem because quantum computers need to be exceptionally stable to carry out accurate computations. To solve this issue, scientists are working on quantum error correction, a complex method to detect and correct errors in quantum calculations. However, this technology is still in its early stages, and there is a huge cost and resource commitment involved in building systems that can manage and correct quantum errors on a large scale. High costs and infrastructure demands. Another significant challenge is the cost and infrastructure requirements. Quantum computers don't function well at normal temperatures. In fact, they need to operate at near absolute zero, which means maintaining these machines requires extremely expensive cryogenic technology. These systems are both difficult to build and expensive to operate. On top of that, the physical infrastructure needed to house a quantum computer is still in the early stages of development. Unlike traditional computers that sit comfortably in data centers, quantum computers require a highly controlled environment to ensure the qubits can remain stable. Scalability. Building a quantum computer with thousands or even millions of qubits is still a distant goal. Right now, companies like Google and IBM are making impressive strides in increasing the number of qubits in their quantum processors. But there's a critical limitation. The more qubits you add, the more difficult it becomes to maintain stability, prevent interference, and manage error correction. The race isn't just about building more qubits, it's about scaling quantum systems while keeping them stable and functional, which is proving to be a much bigger challenge than anticipated. Quantum computing in the global race, a geopolitical challenge. As if the technical challenges weren't enough, quantum computing is also becoming a geopolitical battleground. The race to build the first truly functional and scalable quantum computer isn't just about advancing technology, it's about national security, economic competitiveness, and global power. The United States, China, and Europe are all investing heavily in quantum research. The US government recently passed the Quantum Innovation Act, with a $1.2 billion investment aimed at supporting quantum research and securing the nation's technological leadership. Similarly, China has made quantum technology a central part of its national strategy, pouring resources into both military and commercial applications. In Europe, the European Union launched the Quantum Flagship Program, with €1 billion earmarked for quantum research, aiming to catch up with China and the US. In addition, countries like the UK, Australia, and Japan have also been investing heavily in quantum research, understanding that whoever leads in quantum technology will have a significant competitive edge. But the stakes are even higher than just economic growth. Quantum computing holds the potential to completely disrupt fields like cryptography. If quantum computers can break today's encryption systems, which are built on classical computing, they could undermine the security of the digital infrastructure that powers everything everything from banking to government communications. This potential threat has spurred nations to develop quantum-resistant encryption, a new set of algorithms designed to protect data from quantum-powered cyber attacks. With all these advancements ahead, I'm curious, how do you see quantum computing changing your world? Will it be for the better, or will the challenges prove too difficult to overcome? Drop your thoughts in the comments below, and make sure you subscribe for more deep dives into the future of technology. We've explored how quantum computing promises to reshape industries and tackle problems that once seemed insurmountable. Google, IBM, and other tech giants have made remarkable progress, but we're still in the early stages of this quantum revolution. As quantum computing evolves, the challenges will become more complex, but so too will the solutions it provides. From optimizing drug discovery and revolutionizing AI to securing our digital world with quantum encryption, the potential is enormous. We may be just a decade or two away from seeing quantum computers integrated into our everyday lives. Though we're far from seeing quantum computing in every home or business, its future is incredibly bright. The race is on, and as we've seen, both the public and private sectors are betting billions to unlock its vast potential. Will quantum computing change everything as we know it? The answer is likely yes, but it'll take time. And as the technology matures, we'll be watching every groundbreaking development along the way. Engagement prompt. If you're as excited about quantum computing as we are, make sure to hit that like button, subscribe to Tech AI Vision, and turn on notifications so you don't miss any of our deep dives into the most exciting tech on the planet. What do you think? Will quantum computing live up to the hype? Drop your thoughts in the comments below. Thank you for joining us on this journey into the world of quantum computing. The future is quantum, and it's just getting started.